Hello everyone, welcome to our channel Code with Sunny, and today I am going to talk about the problem remove nth node from the end of the list, and index number is 19, and the problem is of one of the medium type problem of LeetCode. Okay, so let's discuss the problem now. Given the head of a linked list and we have to remove the nth node from the end of the list, which is also equivalent to length minus n plus 1 node from the beginning of the linked list, and we have to return its head after deleting that nth node from the end of the linked list. And there is a follow-up that is given to us. Can you do this in one pass, that is in one traversal of this entire linked list? Okay, so before moving further to understand this problem statement, if you have not done one of the good problems of LeetCode, that is swapping nodes, swapping kth node from the beginning and kth node from the end of the linked list, this problem will become easier after doing that problem. That is, in that problem, it is only we have been only told that we have to do from both, that is kth node from the beginning and kth node from the end. And in this problem, this becomes much easier from with respect to that problem. That is, we have to just focus on nth node from the end of the list. Okay, so I will recommend, if you have not done yet that problem, so do search in on the internet and find it out how that problem can be done. Okay, so coming back to this problem, that is remove the nth node from the end of the list, let's analyze how this is going to be done and find out the best solution of this problem. Okay, so let's first look over the constraints. That is, sometimes in many of the cases, constraints can be very much useful to find out what should be the good solution of this problem. Okay, so number of nodes can go up to 30 and nodes values up to 100. Yes, this is, I think, sufficient uh, to have O of n solution, or you can have O of n square solution, but it doesn't need for that solution. We should have to done in one pass, and it should be like O of n solution, and that should be one of the efficient solution. Okay, so let's find it out how we are going to do this. Okay, with the help of example, let's first understand, and then we will code it out to find out the good solution of this problem. Okay, so let's move further. Okay, so here you can see I have taken one of the linked list. Okay, where you can see the length of the linked list is going to be 8, and let's say we have to find out, let's say we have to delete the k equal to 3 third node from the end of the linked list. So how we are going to do that? That is, if you focus it on, then I am going to talk about this node, that is deleting this node value, that is just eliminating this from the linked list. That is, we have to do, that is, we have to just change the pointer, next pointer of this e, pointing to this node g. So we can easily do this in open operation, but in spite of that, the main thing, that is how we are going to find it out the kth node from the end. This is going to be very much important. So let's understand how we are going to find out kth node from the end of the linked list. Okay, so let's say I'm going to iterate from the beginning of the linked list, and whenever I'm going to find it out, that is kth node. Okay, so let me first complete. That is, whenever I am going to iterate, let's say I am going to iterate from the beginning of the linked list, and I am going to find it out kth node from beginning. Okay, so if we have found the kth node from the beginning, it means that the remaining number of nodes to the right of it is actually n minus k plus 1, where n is the length of the linked list. Okay, so if we have found the kth node from the beginning, it means that there are n minus k plus 1 nodes to the right of this node, including this node. Okay, so okay, so it means that if we have to find out the kth node from the beginning, okay, kth node from the end, so we must assign a new node, let's say nod, new node equals head, and this head is actually the head of the linked list. Okay, so if we have defined the kth node from the end, just start iterating from the beginning of the linked list, and whenever we found the kth node from the beginning, I am going to assign an extra node, that is let's say node equals head. Head is going to point at the beginning of the linked list. Okay, now just to think for that, if we are searching for the kth node from the end, it means that this length is going to be k, and let's say this remaining length is going to be n minus k plus 1. Okay, so it means that we have to iterate n minus k plus 1 nodes more after reaching so that we can reach the kth node from the end. Okay, now let's just focus it on one thing, that is we have already iterated the kth node, we have already iterated the k nodes from the beginning. It means that the remaining n minus k plus 1 nodes including my current node should be iterated, and this is going to be left. Okay, and for finding the kth node from the end, we must iterate n minus k plus 1 nodes from the beginning also. Okay, so this gave me the idea that when I have just encountered the kth node from the beginning, I must assign an extra node, node equals head, and I am going to just increment node equals nodes next. Okay, so I'm going to just complete it out. Node equals nodes next after every iteration after this kth node I have found. Okay, so overall I'm going to summarize one thing, that let's start iterating from the beginning of the linked list, and whenever I found the kth node from the beginning, it means that there are n minus k plus 1 nodes to be iterated to the right of it including my current node. So at that moment I am going to assign an extra node, node equals head, that is going to point at the head of the linked list, and after that iteration including my current node, that is kth node from the beginning, let's say kth node from the beginning is this one. Okay, so when I encountered starting from the beginning, when I encountered this node, I will make node equals head at this position, and after every subsequent iterations of this nodes, I will increment node equals nodes next. And why I am going to do that? Because the remaining number of iterations for visiting nodes would be exactly equal to n minus k plus 1 including that node. So remaining number of nodes is n minus k plus 1. So if I will increment this node equals head exactly equal to n minus k plus 1 times, I will reach, you can see I will reach the kth node from the end, because kth node from the end is exactly equal to n minus k plus 1 node from the beginning. So this is the basic key concept of this entire problem. That is how we are going to find the nth node from the you can say nth node from the end, which is actually I have taken over k as well to avoid the confusion between n and k. Okay, so k is basically the kth node from the end, and n is basically the end length of the linked list. Okay, so let's just solve this problem. Now how we are going to solve this problem, like deleting this node from the linked list, that is kth node from the end. So for doing that, we have to just maintain one extra pointer, that is previous. If we are going to maintain the previous, whenever I encountered the, you can say the kth node from the end, and if I have encountered that, my previous will point to the this one, that is e. So I will just make previous next equals my nodes next, and this node is actually the kth node from the end, nodes next. And this is the only modification that I have to do, because so that e would point to now g. Okay, so I will just understanding that f is going to be deleted in my linked list, so it should be like a b c d e, and then it goes to g and then h. Okay, so let's move further to find how we are going to implement this with the help of this C++ code. Also, if you're not going to understand this entire scenario, no need to worry about it. I'm going to also explain while I'm completing my coding part also. Okay, so let's move further for now. Okay, so here you can see I have the C++ code written over here. So let's talk about how I'm going to implement this scenario in the best possible way. Let's say you can see I have a list node as initially assigned as null and previous initially assigned as null, and this current equals head, which is used for iterating in the linked list. Okay, iterating in the linked list. Now you can see I have current, while current is not equal to null, while still I haven't iterated the entire linked list. Just decrement n every time. And okay, so let me talk about this step first. If n is going to be 0 at any time, I will assign node equals head. Uh, this is because you can easily see kth node from the end is exactly equal to the kth node from the beginning. Okay, sorry, kth node from the end is going to be exactly equal to this length minus k plus 1 node from the beginning. Okay, so let's say I have this one. Okay, so let's say I'm at this one. So this means that this length is going to be Okay, so this node is going to be n minus k plus 1 from the beginning. This is k plus 1. This is kth node from the end. So when I've encountered this kth node from the beginning, I will assign node equals head, so that after remaining iteration for n minus k plus 1 nodes, so that each time I'm going to increment my node equals nodes next. So I will reach the kth node from the end after the entire traversal of this linked list. Okay. So this is the main basic key idea. Okay. So whenever I encountered n as 0, I will assign node equals head, so that after completion of the entire traversal of this linked list, I will have node address exactly equal to the kth node from the end of the linked list. Okay. So now if node is not equal to null, that is we have already encountered the kth node from the beginning. It means I have to just make some changes, that is previous equals node and node will be assigned as nodes next. Okay. And I have to do this while entire linked list is still not traversed. Okay, so at the finally I have to delete the node. So if there might be possible that node to be deleted is the head node, that is I am going to check with the help of previous value. That is if previous is exactly equal to null, just we have to return nodes next. That is linked list will start from the nodes next because this node is going to be deleted. Otherwise, if I am going to delete this node, it should be like previous next, it will be equal to nodes next, and finally return the head. Okay, so let's submit this code and check it out if this is if this is going to be an efficient solution of this problem or not. Okay, so runtime is 0 ms and faster than 100% of C++ online submissions. Okay, so if you have any doubts, do let me know in the comment section of the video, and I will ask the viewers to like this video, share this video, and subscribe to our YouTube channel for latest updates. Thank you for watching this video.